Welcome everyone. Thanks for joining our webinar today. Today's webinar is Deliver High-Performance Virtual Network Infrastructures for OpenStack Deployments. Today we have the pleasure of having two presenters with us today. Our first presenter is Valentina Alaria, Director of Training at PLUMgrid. Next up is Eyal Gutkin, Director of Big Data and Cloud Market Development at Mellanox Technologies. And without further ado, I'd like to turn things over to Valentina.
Thank you. Welcome, everybody. So today we're going to discuss, as introduced, a high-performance network for OpenStack deployment. And we're going to start talking a little bit about what is the driver behind new technologies and new products being introduced in this space. What I like to start from is to look at the landscape of your environment, what is driving changes very, very rapidly to the infrastructure. And the main driver really relies on in the application space. There's new applications that are being deployed, and there's applications that have new type of requirements. And there's also underneath a very rich ecosystem, starting with OpenStack as a big driver of this ecosystem, as well as the availability of white box and new gear. And cloud, it's a very broad term. What we're going to concentrate on here today is the network infrastructure for this cloud deployment. And we're going to break the webinar in two parts. We're going to start from the physical network infrastructure layer, and that's what Eyal is going to cover. And what are some of the requirements of the physical network infrastructure layer, and what are some of the new advances in technology and products that Mellanox is delivering to the market. Again, keeping in mind that what we're doing is to enable our users to bring more easily applications to the market. And then we're going to go to the next step, which is the virtual network infrastructure layer, which is something that gets deployed on top of your physical infrastructure. And what we're going to look at is how the two layers can better work together. Leveraging some of the advanced technology that Mellanox brings to the market, together with the PLUMgrid product, give you the flexibility and on-demand which is needed by new cloud infrastructure, together with high performance. So let's start with the physical network layer.
Thank you, Valentina. Appreciate everybody's time today, and let us start. So this slightly complicated slide here is actually describing the OpenStack that has become a dominant cloud management orchestration and provides an open source framework to handle network and management as well. Mellanox designed an end-to-end OpenStack cloud solution to offer seamless integration between its products and OpenStack services. Our efforts focuses mainly in the Nova, which is the compute part of the OpenStack, Cinder, the block storage, as well as the Neutron, which is the networking packages for OpenStack. Our solution provides a unique functionality that includes application and storage acceleration, network provisioning, automation, hardware-based security, and isolation. Avana and Highhouse, which are Highhouse is the latest release, support InfiniBand as well as Ethernet with Mellanox components for Nova, Cinder, and Neutron. This means that now that using Mellanox Interconnect, adapters, and switches, and OpenStack releases, customers can gain significant improvement in block storage access performance with Cinder. In addition, customers can deploy an embedded virtual switch to run virtual machine traffic with bare metal performance, providing hardened security and quality of service. Everything is simple integration with the open source solutions. Mellanox has partnered with the leading OpenStack distributions to allow customers confident deployments of OpenStack Cloud with proven interoperability and integrated support to the different components. We will review Mellanox CloudX, our reference architectures, and blueprints for the different cloud distributions. Let's start with the VXLAN notion. VXLAN is a virtual extensible LAN. It's a network virtualization technology that attempts to alleviate the scalability issues associated with large cloud computing deployments. It uses VLAN-like encapsulation, as seen in the graph, to encapsulate MAC-based layer 2 Ethernet frames within a layer 3 packet. Common offload techniques such as hardware segmentations, assembly reassembly, checksum offloads, And CPU core scaling, like RSS and TSS, cannot operate on the VM or the virtual machine TCP packet, the inner payload. The workload of generating the transmitted packet is handled by the physical CPU on the server hosting the virtual machine. This workload creates a significant overhead on the physical server. With the Mellanox Connect X3 card, the inner packets checksum are offloaded to the hardware. In addition, the large send offloads for the inner package, the GROs, are offloaded from the host CPU as well. To improve parallelism, we enable multiple receive and send queues and enable packet steering based on the inner payload. The results can be seen in these charts. The blue bars represent the bandwidth performance and the CPU utilization for non-VXLAN traffic between single, dual, and 3 pairs of virtual machines, each virtual machine is located on a different physical server. The red bar represents the software implementation of VXLAN capabilities. As we have mentioned before, it enables a large-scale cloud deployment on a layer 2 semantics, encapsulated within a layer 3 implementation. We can see that the bandwidth performance drops by almost 5 times between the non-VXLAN and the VXLAN implementation. CPU overheaded quadruple, and basically we clog the server. Now, with the implementation of the hardware offloads using Mellanox Connect X3 Pro card, we are able to restore the same performance that we had without the VXLAN encapsulation. It means that we can maintain the advantages of VXLANs in terms of isolation and scalability, and without paying any penalties on the bandwidth or the CPU overhead. The Mellanox VXLAN Linux implementations include support for the Linux Bridge and Linux OVS, the Open vSwitch, as well as upstream to the kernel drivers, and it's inboxed within the kernel 3.12 and above. What this means in terms of the performance that we are able to get. It means that with the OpenStack solution, we extend the Cinder project using ISER. ISER is iSCSI over RDMA. And leveraging the RDMA, we are able to provide almost 4 times better data throughput and requires only 20% of the actual CPU that used before. With Ceph, which is a leading software-defined storage solution that offers both block and object, we are able to provide almost bare metal capabilities to the cloud solution. If we deploy a Ceph block solution, it requires a very careful design of the network. When using the high performance capabilities that Mellanox adapters and switches bring into the market, we are able to provide 150% better throughput over any 10 gigabit per second network. Ceph, in its designs, offer the option to use both public and cluster networks. The cluster networks provide the needed separation between the client traffic as well as the software, as the Ceph object storage device. With that separation, we are able to provide with a complete bandwidth capability to the actual user and offloading the cluster networks into a different, more high-performing network. With storage node that has SSDs that can generate easily over 25 gigabit per second of data throughput, users cannot afford to have a clogged network, which is sharing a single 10 gigabit Ethernet for public and cluster network. With ISER and high-performance network design, the cloud storage infrastructure deployments can perform as expected by the IT managers, providing the needed resiliency and throughput while lowering the user wait time. Moving to the end-to-end SDN interconnect solution, the software-defined network provides data centers managers with the flexibility to manage network services decoupled from the hardware system they are deploying, such as the end control system is the OpenFlow framework. In the OpenFlow framework, the network control is directly programmable and completely decoupled from the infrastructure layer. The network is centrally managed from the SDN controller, as can be seen on the right side hand, that maintains a global view of the complete network. The abstraction of the control mechanism lets the network administrator dynamically adjust the network traffic based on the actual organization needs. Mellanox Neutron agent, as can be seen on the left side, on the servers themselves, it provides a seamless integration to the SDN network. In addition, a complete end-to-end solution together with a Mellanox 10 and 40 gigabit per second Ethernet switches. The addition of overlay networks, as mentioned before, provides the network administrator with a single high-performing network infrastructure, future-proven to enable cloud deployment. I would like to move into our reference designs. We call them CloudX. Those are platforms to build an efficient private and hybrid clouds. They provide the needed building blocks for truly scalable and high-performance cloud infrastructure based on OpenStack distribution. CloudX enable cloud applications to operate at the highest efficiencies by offloading all the network overhead to the hardware installed in CloudX solutions. CloudX is a reference architecture for private and hybrid cloud deployment, helping organizations to make sure the computing resources are efficiently used. CloudX reference architecture can scale from single rack to dozens of racks in every data center. As mentioned before, storage and compute solutions that we already deployed, like Cinder and Ceph, are available for the users and help them dynamically scale without compromising on the actual performance. The reference architectures are available on Mellanox website. I'll encourage you to go to our website and download the next cloud deployment that you're looking for. We are completely agnostic for every storage solution and server vendor and provide an end-to-end interconnect solution for a cloud deployment. I would like to mention an effort that we're doing in the industry. We call the Cloud Advisory Council. It's a not-for-profit organization that we aim to provide certification and publications of best practices for cloud deployment. There are several tracks in which the Cloud Advisory Council is operating. First one is the ecosystem that helps build vibrant community around cloud solutions. And the Cloud 500 builds a benchmarking effort to provide users with the measurable and quantifiable measures to understand their cloud solutions and their acceptance levels. The High Performance Cloud track provides new cloud technologies with the needed exposure and support. So if you have new ideas in this space, we will be more than glad to hear about them and help you guys promote them. Please feel free to join the Cloud Advisory Council. We would like the community to grow and have a powerful say in this market. To conclude my part in the hardware settings, Mellanox Interconnect, as you can have seen, provides the private hybrid cloud solution with the performance, ease of integration, and scalability they need. So when you're looking for a VXLAN or NV-GRE offload from a hardware perspective, definitely a Mellanox Connect X3 Card Pro is the card for it to use. We provide a seamless integration with all cloud distributions, and we provide a scalable, high-performance multi-tenancy solution or any cloud orchestration that is out there in the market. With that, I would like to provide Valentina from PLUMgrid the stage and continue and explain the virtual network infrastructure design solution.
Thanks, Yael. So we're now going to move into the virtual network infrastructure design session. So for those that are not familiar with the virtual network infrastructure, I want to start with this diagram, and hopefully it will help you place it in the overall cloud stack. So if you look at this drawing here, you have your physical layer, your physical infrastructure layer with your computing, storage, and network. And then you have your virtual infrastructure layer. Now, the virtual network infrastructure is nothing but the corresponding piece to virtual compute and virtual storage for the network infrastructure. It's something that enables the same programmability, automation, on demand that virtual compute and virtual storage give for the computing and storage piece, now for the network part. And the beauty is that the virtual network infrastructure will be able to plug directly into your cloud management platform, being, for example, OpenStack, and your business logic, so that you can very easily start deploying applications on top of it. As I said at the beginning, applications are really the main driver for your cloud design, are those that define what type of infrastructure you need, what type of design, what type of storage connectivity. I want to look at a little more details at the exact requirements for the network infrastructure and why do we actually need an extra layer, this virtual network infrastructure. There's 5 main pillars here. The first one is the scalability and multi-location of a cloud. Many of the customers we work with have existing infrastructures that they want to transform into a cloud environment. And so the ability of having a virtual network infrastructure layer that is hardware agnostic, that can just be layers on top of what you already have in place, that brings the agility of cloud is something that is extremely fundamental. At the same time, especially for a specific type of applications, there's a requirement for high performance. And so this is something that we'll look in a lot more details later on in the presentation, looking at how the right hardware infrastructure can enable highest level of performance in the virtual network layer. And obviously, many of our customers start with a single site deployment, and then they start scaling across multiple sites. So the virtual network infrastructure plays a fundamental role in enabling your cloud solution to grow and scale out as your needs evolve and go from single site to multi-site. The second pillar is a very intrinsic proposition of cloud, which is cloud has to be multi-tenant. You want to be able to have multiple users. You want to be able to have multiple applications. You want to be able to have multiple tenants that have to have completely independent environments, completely firewall environments. Security is, in fact, another big component of delivering a cloud solution. When you have multiple users or applications that are sharing the same infrastructure, you want to be able to build a solution that is aware of the identity of either the user or the application itself, that can enforce policies easily, and can also enforce policies back to the first pillar in a scalable fashion. So a lot of these solutions out there leverage more traditional firewalling infrastructure with the insertion of appliances. We're going to look at how PLUMgrid delivers some of these policy enforcement in a more distributed way, and also enabling users to encrypt full tenant environments where needed. The fact that the cloud has to be open and extensible. This is another key tenet of building a cloud solution. You're building a cloud today, and you're not necessarily aware of the requirements of this cloud in a year or 3 years from now. So you want to be able to select something that will take you through your changing needs and requirements. So environments that have open API and data models and interfaces and the ability to extend through SDKs. Kind of getting you ready for, again, the unknown, for what you cannot foresee at the moment as you roll more services out. And then clearly agility and simplicity. So being able to create things on demand. You have new users, new applications can come in. You want to be able to create new environments for them. Same as today, you can spin up very easily a virtual machine. You want to be able to do the same for the network infrastructure. And the last but not least, the fact that every cloud solution has to be fully automated. And you want to be able to provision everything in a matter of seconds. So something that the virtual network infrastructure helps a lot with, if we roll back for a second to the previous slide, is that if you want to roll new applications and you have to go and continuously modify the physical network infrastructure, this is very error prone, this is very, very failure prone. So the virtual network infrastructure creates this layer that lets you have a very stable, well-designed physical network infrastructure that takes care of performance, reliability, bandwidth, and have the virtual network layer on top of it, taking care of the all on-demand provisioning and creation of multi-tenant environments. So at PLUMgrid, we believe that just a controller or a simple point product solution is not enough to be able to take customers to the future and satisfy these 5 requirements. So we built more of a platform approach, and I'm not going to go into all the details of the platform today, but that's definitely a very interesting topic. But just keep in mind that the architectural approach is more of a platform, and what we're bringing to the market is a point product that is built on top of this platform approach. So the product that we have today that works together with the Mellanox ConnectX Pro to deliver high-performance network solution is what we call PLUMgrid OpenStack Networking Suite. It's a software-only solution that brings virtual network infrastructure two OpenStack clouds. And in particular, the one component that we bring to the market that we give customers is what we call secure virtual domains. So let me help you understand what a virtual domain is. The easiest way to picture a virtual domain is to think about it as a virtual private data center. So something that you can create in a matter of a second that is only for you. It's your private environment and has all the components that your physical data center has, and it can be created on demand in software, and you can create as many of those environments as you need. And if you look, virtual domains are those boxes you see on top of this picture, and they're represented as a network topology. So for somebody that has a network background, this looks very much like a Visio diagram, something that you would draw for your physical data center. What is different here is that you're actually defining your environment, your full environment, your switching needs, your routing needs, your load balancing, your security needs through the virtual domain concept. And all of these will be implemented for you in software. And because you can create these environments in a matter of seconds, you can very easily build multi-tenant environments where you can host hundreds or thousands of tenants without the need to actually go and procure more hardware, without the need to go and reconfigure your hardware infrastructure. So each one of these virtual domains is completely isolated. As we said before, security is at the core of this solution, so that workloads that belong to a single tenant cannot be seen or interact with workloads that belong to a separate tenant. And security policies are applied at the boundary of this virtual domain. Now, virtual domains can also provide storage infrastructures or booting infrastructure. So don't think about virtual domains as just something that your tenants will be able to leverage. Virtual domains are also something that you as a cloud operator will be able to use and bring immense benefit, because they will help you connect your storage infrastructure in a more flexible way. They will help you boot your cloud infrastructure without actually having to configure VLANs everywhere, for example. Now, those virtual domains get created automatically through a framework, through a cloud framework. And in particular, the product that we're bringing to the market is very much targeted for OpenStack clouds. Again, we strongly believe in the ecosystem that is being created around OpenStack and the momentum that this project is now taking with production environments being rolled out. But you could very easily replace OpenStack with another framework if that's what you have in your infrastructure. But the idea here is that OpenStack is the cloud management system that drives the creation of these multi-tenant environments, the secure virtual domains, whenever needed. As part of the PLUMgrid OpenStack networking suite, we provide out of the box a very rich portfolio of networking features, something that you can consume as needed. I said, even thousands of times if you have thousands of tenants. And these set of features that we bring are, as I mentioned before, the switching functions, the ability to create routing functions on demand, NAS, security, load balancing, but also the ability to leverage third-party service appliances that you might already have in your infrastructure. And these we do through partners where we insert their service into our solution. Now, if we look a little more in detail at the partner ecosystem, this is a very interesting point for us, where the PLUMgrid OpenStack networking suite can support a very diverse set of partners. I briefly touched upon the layer 4 to 7 partners, which is something that is very key to the solution that we bring to the market. But we also work with a broad array of partners from the switching and routing space, obviously Mellanox for the hardware acceleration, to the server hardware storage and the hypervisor. PLUMgrid, as I mentioned before, is mainly targeted at OpenStack. PLUMgrid Networking Suite is mainly targeted at OpenStack solution. It's certified to work in all the major distributions, and you can start right out the box leveraging PLUMgrid integrated with OpenStack through the Neutron plugin. As I was mentioning before, Neutron is the plugin that enables modular network components to be plugged into OpenStack. So PLUMgrid supports Neutron plugin so that you can leverage it as part of an OpenStack deployment. as I mentioned earlier, what we bring to the market is not just something that will bring value to your tenants, but you can look at it throughout the entire life cycle of your cloud. As we work with many customers out there rolling out a large cloud infrastructure, we understand that the problems and the challenges happen throughout the life cycle, throughout all 5 phases of building a cloud. Obviously, building a cloud, it's very hard. Securing it and operating it can be even harder as a challenge. And so what we do with the PLUMgrid OpenStack networking suite and our holistic virtualized network infrastructure is to help from the design phase to the booting infrastructure to the actually using your cloud all the way to the operating and maintaining. And obviously, if you have ever been maintaining and operating a large cloud infrastructure, you'd agree with me that having strong monitoring and troubleshooting infrastructure in place is key to be able to actually operate it. And so the beauty, one more time, of a virtual network infrastructure layer is that it can give you monitoring and troubleshooting in a much more distributed way, such that it's pervasive, it's in every hypervisor, it's in every server, and it can give you a view of the distributed environment. I want to take it down to the technology a little bit so that you can see where PLUMgrid and Mellanox come together. So this is just a diagram of the underlying technology. As I said before, we have a platform underneath the product. And if you're familiar with software-defined networks in general, there is often the concept of a controller. I just want to help you see how PLUMgrid is a little bit different from a technology perspective, so that you can understand where, again, the Mellanox technology and the PLUMgrid technology come together. So on the left-hand side of the picture, there is what we call the director cluster. The director cluster is really the brain of the PLUMgrid solution. It's the component that interacts with the cloud management system layer, and it's the component that is aware of all the hypervisors, all the virtual machines, all the components that are being deployed in the environment. It's a cluster, so it's fully HA, it's fully redundant, and it's the one that is also going to interact with OpenStack, for example, to help you create virtual domains. So through the interaction between OpenStack and the director cluster, you'll be able to define the environments you need for your application. The other component, which is something that is very different that PLUMgrid brings to the market, is the concept of the IOVisor. And the IOVisor is a software data plane that we deploy inside your servers. Now, some of you might be familiar with the concept of OpenVSwitch. Now, the IOVisor is quite different from OpenVSwitch, and this is also one of the reasons why we can achieve a very high level of performance working with Mellanox. So the IOVisor is a fully programmable runtime environment that lives inside the hypervisor server. It's kind of deployed in the same place as OVS, so inside your kernel. It only has kernel component. If you're familiar with OpenVSwitch architecture, we don't have a user space component which we punt packets to. The IOVisor is the one place in your infrastructure where we actually implement all the networking features and functionalities that I was describing earlier on. So when I said that you can create a virtual domain, which is your private virtual data center, and you can define that you want some switching, some routing, some load balancing, and firewalling. What I meant is not that you're going to create virtual machines for all of those. All these features and functionalities are implemented in a distributed fashion in software inside your hypervisor layer through the IOVisor. And all these features and functionalities will be provisioned on demand inside the IOVisor as you create more and more of these virtual domains for your tenants. Now, a little more details as well here, and to show you how we leverage the VXLAN encapsulation, I put together a simple picture that shows on the top the virtual domains that you have created. And what happens under the covers here is that the virtual domain will have some workloads that are connected to the virtual domain. For example, in this picture here, the blue tenant number 2 has 3 virtual machines that are spread across 2 servers in your infrastructure. Now, as your virtual machines come up, they will be recognized as belonging to tenant number 2, and they will be placed in the correct virtual domain logically by the director, by the brain of the PLUMgrid solution. What happens under the covers is that we leverage a VXLAN infrastructure, a tunneling infrastructure, to implement the virtual domains, to have the virtual domains provide the features and functionality that you've defined for tenant number 2, completely independent of the physical network infrastructure. This is something that I was mentioning earlier. What is fundamental of this design of physical network layer plus virtual network layer is that your physical network layer stays the same, remains untouched and unconfigured, and on top of it, you layer the virtual network infrastructure that gives you the on-demand and the flexibility. And the way we layer it on top is through the VXLAN infrastructure. So by building these tunnels and by having our IOVisor, our software kernel module implementing all the features that you have defined for your tenants, we bring the virtual domains to the market. Now, as I all mentioned earlier on, when you start building VXLAN tunnels on top of a physical infrastructure, there's many layers where the performance can degrade. And so one of the interesting value proposition of looking at PLUMgrid plus Mellanox is that we can actually improve the performance of the solution by leveraging the two components together. So what I'm showing here, and there is a lot more details on a joint one paper that you can find on the web, on the PLUMgrid and Mellanox website. But what I'm showing here is two testings that we've done with PLUMgrid OpenStack Networking Suite and the Mellanox ConnectX Pro, where on the left-hand side, we're showing the throughput with and without VXLAN offloading. And the beauty of this graph is that if you look at a software-only solution with no hardware offloading, as you increase the number of VM pairs, the performance will pretty much the ceiling will be around 10 gig. As you start leveraging the hardware offloading of the Mellanox ConnectX Pro, you'll be able to boost your performance all the way to close to 40 gig. It's actually 36 and something in this specific testing infrastructure that we have used. And so as you increase the number of VM pairs, you'll be able to very quickly get to level of performance that are extremely significant. And the other component of it, where the hardware offloading plays a very important role, is that as you increase the number of VM pairs and as you go all the way to your 36 gig of throughput, your CPU utilization increases very, very slightly. So in this graph to the right, you see that the CPU idle percentage is pictured here together with the throughput. And the fact that why the CPU idle percentage is so fundamental is obviously because the same server where you're running the PLUMgrid IOVisor, the same server where you're running the Mellanox ConnectX Pro, is also the server on which you're running your tenant virtual machine and in which you are hosting your application. And so the benefit of leveraging the two components together is that you can get to the highest level of performance with the minimal impact on your CPU utilization. And with this, I'm concluding, and we're opening this for questions. I see a few lined up in the Q&A.
Thank you, Valentina. So as she mentioned, we will formally open up the Q&A session. So what I'll do is I'll go ahead and read off the questions and then have our presenters answer the questions. So our first question is VXLAN offload available when using InfiniBand?
This is Eyal. Some of the offloads are available. Some of them are in beta. The actual Neutron plugin is upstream into the OpenStack Neutron component. So there is one public implementation out there. If the person who asked the question can send me an email, I'll be more than glad to share the actual implementation that this partner has used.
Thanks, Eyal. Our next question. Can Mellanox spend a second on the most recent 100 gigabit InfiniBand announcement and the OpenStack support?
Thank you for the question. Actually, this presentation scope is beyond that announcement. Definitely, we will have implementations and support for OpenStack for our recent announcement, but this is a future-looking feature, and it's part of our roadmap. Please stay tuned to our announcement and check them frequently.
Thanks, y'all. We have another question. What is the difference between IO Visor and OVS?
All right, thanks for the question. So in a few words, I don't want to go into too much detail there, but the main fundamental difference is that OVS was created and defined as an open flow virtual bridge. So a lot of the underlying infrastructure is built such that you can very easily map open flow to OpenVSwitch. So think about it as, matching an actions, tables, and very limited support in terms of advanced features and functionality. It was designed to implement some basic switching, no routing, very limited tunneling, and so on and so forth. And very hard to extend as well because, think about it as a hard-coded software data plane that has been designed to support a specific array of features and functionalities. When we designed the IO Visor, we wanted to take an approach that will, again, enable customers to build an extensible cloud infrastructure. And so the IO Visor, it's an extensible runtime environment. So think about it as kind of an empty box at the beginning of time. It's something that doesn't have any feature and functionality. And as you load the PLUMgrid network functions, being the bridge, the routing, the security policies, the NAT, the DHCP, and so on and so forth, it becomes in software capable of implementing these features. And it's extensible because you can load new features and functionalities without actually requiring to reboot or recompile your kernel or to reboot your hypervisor. So it's quite a fundamental difference. And one practical piece that I briefly mentioned earlier on is that because OpenVSwitch is built as an open flow software data plane, it has a cache and a mist architecture where if you have already an entry for a specific flow, you will stay in the kernel space and have pretty good performance. But as soon as you miss that flow, you're going to be pumped to user space components. And that has a pretty big impact on your performance. PLUMgrid is not a flow-based architecture. So a lot of these punting and sending to user space does not happen there. And so these also enables this highest level of performance that we see in this picture.
Thanks, Valentina, for talking about the I/O. So there's an additional question. What are the functions of the IO Visor gateway? Is there anything else you can add?
So the IO Visor gateway, it's a component that we leverage to interconnect with either external networks or anything that is legacy infrastructure. So the gateway is something that will take your VXLAN infrastructure, that will take the PLUMgrid virtual domain and map it into whatever external component you have. So it's usually something that will be deployed in your data center boundaries to enable for a tenant virtual machine to interconnect with something that sits in the internet. It's also a component that we use to onboard and bring, if you have any physical or legacy resource, like let's say a physical server that is sitting somewhere in your infrastructure that you want to bring and make part of this solution. We use it to interconnect with storage, for example, anything that is non-virtual machines is not sitting on a hypervisor. But from the point of view of the architecture and everything that I was describing earlier in terms of being a software data plane, being completely extensible and runtime, that applies both to the IO Visor that sits within the server, the hypervisor, as well as the IO Visor that provides the gateway functionality.
Thanks, Valentina. We have another question. How many OpenFlow 1.0 flow entries does the NIC support?
I don't have that information at hand right now. Let me post that answer in one of our blogs in the next few days, please.
All right, looks like we have another question. The question is, PLUMgrid OpenStack networking suite natively provides all those features shown in the diagram. For example, LB and FW. Is LB/FW offered as a software cloud service or VM?
Thanks for the question. So all the PLUMgrid features that I described are offered in a fully distributed fashion. When I mentioned some of the firewall and load balancing offerings that we also have through partners, those are implemented as VMs, but PLUMgrid has security policies and functionalities we implement fully distributed in the iOVisor. So if you're interested in understanding more in details how that works and exactly what, for example, the security policy feature will give you, definitely follow up offline and I'll be able to go into more details there.
All right, looks like we have another question. It looks like a follow-up to the iOVisor gateway. What do you mean by it supports Juniper, Cisco, or some other routers? Can you please elaborate?
So I didn't say that we support Juniper, Cisco, or any other router. The way it works is that the gateway is really just interconnecting with anything that is out there. So that can be Juniper, it can be Cisco, it can be Mellanox, it can be anything that you already have in your infrastructure. The gateway will speak legacy networking, meaning it will speak VXLAN, it will speak routing protocols. So there's nothing that we actually have to do per se to support working with this physical infrastructure. We simply layer on top of the physical infrastructure. Now, the gateway function is something that is provided by PLUMgrid. It sits in a separate component in your infrastructure. It can be, either a server, or it can be, a component from a partner that provides this gateway functionality. But we don't go and replace the physical infrastructure. The physical infrastructure is something that you already have in place, that it can be whatever you decide to use for your physical infrastructure. Now, obviously, the reason why we're doing this webinar is because we know that if you choose to use specific physical network infrastructure components, for example, a specific NIC, you will get better or different performance. But from a gateway perspective, we'll be able to interact with whatever legacy infrastructure you have in place.
Thanks, Valentina. So the follow-up question to that would be, so does this mean you support any API integration?
Absolutely. So PLUMgrid has a complete set of API that exposes every feature and functionality of the platform. Now, specifically for OpenStack, we have built already a plugin. So we already built the integration with OpenStack framework, but we have API to access all the features and functionality.
Thanks, Valentina. We have another question. Are the functions provided by the iOVisor, like the firmware, per iOVisor instance?
So the features are distributed. What I mean by that is that you will define a virtual domain. You say, I want to create a virtual domain for a tenant AOL. AOL will need some switching, some routing, and some security policies. So you'll define that infrastructure. And then AOL will start booting up virtual machines. And these virtual machines will be scheduled by, for example, the Nova scheduler across 15 different servers. Now, what will happen is that these features that we have defined for all the switching, the routing, and the security policies will be implemented, distributed across all these 15 servers on which AOL's virtual machines sit. So it's a global feature that is implemented, distributed across the iOVisor. So every VM will see the switching, the routing, and the security policies be enforced within its own hypervisor. Hence, giving the best level of performance and the best level of enforcement, because we can enforce security right at the boundary where the VM starts talking to the network infrastructure.
Thank you, Valentina. Okay, we have no other questions, so that go ahead and concludes our Q&A session. Eyal, Valentina, I'd like to thank you for our insightful presentation today. Looks like we had a lot of really great questions and interest on this topic.
Thank you very much. Appreciate the time of everybody.
Thank you.
All right, and with that, have a wonderful day. Take care. Bye-bye.